Hello students, today we are going to begin a very important topic in mathematics, coordinate geometry. This chapter looks a little technical at first, but I will explain it to you just like a classroom teacher would, step by step. We will study the basics, formulas, and solve examples together. By the end of today's session, you will be confident about the foundation of coordinate geometry. Let's start with the Cartesian plane. It is formed by two perpendicular lines. The horizontal line is called the x-axis and the vertical line is called the y-axis. These two lines intersect at a point called the origin, denoted as 0, 0. Every point on this plane is written as an ordered pair in the form bracket x, y bracket. For example, 3, 2 means move 3 units along the x-axis and 2 units up along the y-axis. Now, this plane is divided into 4 quadrants. First quadrant has plus x and plus y. Second quadrant has minus x and plus y. Third quadrant has minus x and minus y. Fourth quadrant has plus x and minus y.
Sir, may I ask a question?
Yes, please go ahead.
Sir, why is this system important?
Excellent question. Imagine GPS. When your mobile phone tells you your exact location, it is using coordinates on this plane. Pilots, ships, and even satellites rely on this system to know their exact position. Now, suppose we have 2 points, A with coordinates x1, y1 and B with coordinates x2, y2. The distance between them is given by the distance formula, d equals square root of x to minus x1 whole square plus y to minus y1 whole square. Let's solve one. Example 1, point A 3, 4 and point B 7, 1. Now, x to minus x1 is 7 minus 3, which is 4. Square of 4 is 16. Y to minus y1 is 1 minus 4, which is minus 3. Square of minus 3 is 9. Add them, 16 plus 9 equals 25. So distance d equals square root of 25, which is 5 units. Another quick one, point A 0, 0 and point B 6, 8. X to minus x1 is 6, whole square is 36. Y to minus y1 is 8, whole square is 64. Add them, 36 plus 64 equals 100. Square root of 100 is 10 units. So the formula works every time. Next, let's learn the section formula. Suppose a point P divides a line joining ax1, y1 and bx2, y2 in the ratio m is to n. Then the coordinates of P are open fraction mx2 plus nx1 upon m plus n, fraction my2 plus ny1 upon m plus n. This is the internal division formula. Special case, if the ratio is 1:1, then it gives the midpoint formula. That is, m equals fraction x1 plus x2 upon 2, fraction y1 plus y2 upon 2. Let's solve examples. Example 1, A is 1, 2, B is 5, 6 and ratio is 3:2. So x coordinate is 3 times 5 plus 2 times 1 divided by 5. That is 15 plus 2, 17 upon 5. Y coordinate is 3 times 6 plus 2 times 2 divided by 5. That is 18 plus 4, 22 upon 5. So P equals 17 upon 5, 22 upon 5. Example 2, midpoint of a minus 2, 4 and B 6, 8. X coordinate minus 2 plus 6 equals 4, divide by 2 equals 2. Y coordinate 4 plus 8 equals 12, divide by 2 equals 6. So midpoint m equals 2, 6. Slope tells us how steep a line is. The formula is m equals fraction y to minus y1 upon x to minus x1. If the line is horizontal, slope m equals 0. If the line is vertical, slope is undefined. If the line rises left to right, slope is positive. If the line falls left to right, slope is negative. Let's solve examples. Example 1, points A 2, 3 and B 6, 11. y2 minus y1 equals 11 minus 3 equals 8. x2 minus x1 equals 6 minus 2 equals 4. So slope m equals 8 upon 4 equals 2. Example 2, points A minus 1, 5 and B 2, 2. y2 minus y1 equals to minus 5 equals minus 3. x2 minus x1 equals to minus 1 equals 3. So slope m equals minus 3 upon 3 equals minus 1. So slope can be positive or negative depending on the tilt. Once we know slope, we can write the equation of a line. There are three common forms: slope-intercept form, y equals mx plus c, or in slope form, y minus y1 equals mx minus x1. General form, ax plus by plus c equals 0. Example 1, a line passes through 2, 3 with slope 4. Equation, y minus 3 equals 4 times x minus 2. Simplify, y minus 3 equals 4x minus 8. So y equals 4x minus 5. Example 2, line through point 1, minus 2 with slope 1 upon 2. Equation, y plus 2 equals 1 upon 2 times x minus 1. Now let's calculate the area of a triangle formed by 3 points A, B and C. Formula is area equals 1 upon 2 into modulus of x1 into y2 minus y3 t plus x2 into y3 minus y1 plus x3 into y1 minus y2. Example 1, 2, 3, B 5, 7, C 8, 4. Area equals 1 upon 2 into modulus of 2 into 7 minus 4 plus 5 into 4 minus 3 plus 8 into 3 minus 7. That is 1 upon 2 into modulus of 2 into 3 plus 5 into 1 plus 8 into minus 4 equals 1 upon 2 into modulus of 6 plus 5 minus 32 equals 1 upon 2 into modulus of minus 21. So area equals 10.5 square units. Example 2, A 0, 0, B 4, 0, C bracket 0, 3. Area equals 1 upon 2 into modulus of 0 times 0 minus 3 plus 4 times 3 minus 0 plus 0 times 0 minus 0. That is 1 upon 2 into modulus of 0 plus 12 plus 0 equals 1 upon 2 into 12 equals 6 square units.